We're going to do vector addition today. To understand the vector addition, we have to understand the trigonometry. So what is trigonometry? Trig is three-sided polygon, right? And metry is the measurement. All right. So what is trigonometry? Trigonometry is the measurement of a polygon that has three sides. That doesn't help much. So now I'm going to give you a definition that really helps you capture the essence of trigonometry. So trigonometry connects and there start our conversation with 1:1:2 ratio and 1:3 ratio. When we talk about 1:1:2 ratio, we can start our conversation like this, and we can try to find what would be the each angle. This is the smallest, this is the second, this is also this and this are the same size, and this is 2, right? And so we want to find how much is this one, and how much is this one, and how much is this one. One way to find it, 1x plus 1x plus 2x is 180, because sum of the all angle of a three-sided polygon is 180. So you have 4x is 180, so x is 45. So now you know this is 45 and this is 45, and 45 times 2, this is 90. Now we know the angles. But trigonometry also is a study to make a connection between angle and their three sides. So what about this side? This side is x, this side is x, this side is of course 2x, because 2 times x, because this is the longest one. So this is what trigonometry allows us to do. Trigonometry allows to make the connection between three angle, three side. We did. Now let's do this one. If we talk about this one, now we have 1x plus 2x plus 3x is also 180, because the sum of all the angles in a triangle is 180. So 6x is 180. So x is 30, right? This is the smallest, so this is 1. So 1 means, of course, 30. And this is the second biggest, and this is 2. 2 means 30 times 2, 60. And this is the third biggest, or the biggest, 3. 3x. 3x is 3 times 30, which is 90, right? We have the angles. Now we're going to take care, of course, the side. This side is, again, here, this is probably, okay, so this is not 2x. Let's find what this x is. A squared plus b squared is equal to c squared, right? So a is x squared, b is x squared, and c squared is c squared. So c squared is 2x squared. So c squared is 2x squared, square root of 2x squared, and c is square root of x squared is square root of 2. So c is x root 2. So this is x root 2 actually. So now what is this one? This one also you can use the Pythagorean theorem, but to save our time, so anytime you forget, right, you can use the Pythagorean theorem to fix it. So the smallest one would be x, and then the second biggest one, x root 3, and this is 2x. Of course, you can use the Pythagorean theorem to check them. Now, also, when we do the trigonometry, also we're gonna have to make a convention. We have three angles, A, B, and C, and we have to have three sides. The side, so if this is angle A, then the opposite to angle A must be lowercase a. Opposite to angle C must be lowercase c. Opposite to angle B must be lowercase b, and these are convention. Now let's make a more convention. The convention, I'm going to draw some of the angle, right angle triangle. Today we're going to focus on right angle triangle. Okay, so I have 4 right angle triangle. Let's call, I can put the angle, okay, let's call this one opposite, right? And this one adjacent, and this one hypotenuse, right? Hypotenuse is the longest side. If I put the theta, then everything is wrong, right? Okay, all right. Instead of JSON, I can definitely call it A. Instead of JSON, I can definitely call it B. I can call it A, and I call it C. All right, instead of JSON, I also can call it X, I can call it Y, and I can call it R. R is the resultant, right? And R is 1. Okay. Instead of calling X, I can call it sine, I can call it cosine, and I call it, instead of Y, I can call it sine, and of course I can call it r. R is 1 in a unit circle. When we talk about a unit circle, what we are talking about? We are talking about a circle that has lots of point, infinite amount of point equidistance from the center. Now consider 4 dot, right? Right, this is circle, so this must be 2D. 2D, in order to make a point, you have to x and y, right? X and y, x and y, and x and y, right? Okay, now x and y is good, but that's not good enough, right? If I ask you what is your location, if you say x, whose x you are talking about? This one, this one, this one, or this one. So x is not good. Instead of x, we're going to call cosine. Instead of y, we're going to call sine. Okay, no x, y. Instead of x, we're going to call cosine. Instead of y, we're going to call it sine. And so far, instead of x, we're going to call cosine and sine, and cosine and sine, right? Now, if I ask you what is your location, if you say my location is cosine, that's also a problem. Cosine, who is cosine? I can have million of cosine in this circle. Who is cosine are you talking about? So we have to make another convention, and that is we have to put angle 0 degree, 90 degree, 180 degree, 270 degree, right? Now you are saying 0 degrees, 0 degree, and then 90 degree, and 90 degree, and then 180 degree, and then 180 degree, and then 270 degree, and then of course 270 degree. Now if I ask you what is your location on the circle, if you say my location is cosine 270 degree or cosine 269 degree, I know you are here. Okay, so we're gonna follow this convention. To this convention, we're going to start talking about 6 trigonometric functions. We start our conversation with sine. Where the sine come from? Let's see. If there is an earth and there is a moon, the moon is, we can estimate the path of the moon around the earth is circular, right? So let's do that. Let's imagine the path of the moon, and let's cut that path in 4 quadrant, right? 4 segment, 4 quadrant, right? Let's put a wall, and we're gonna project the dot. Let's consider four dots on this circle, right? If you project this one over here, so this must be here, right? If you project this one, this cannot be here, right? This has to be here, but this cannot be here because from here to here it takes more than 0 seconds. So this must be here. This one must be then here, and this one must be then here, right? And there are infinite dots here on this unit circle. So let's put all the dots, right? If you do put all the dots, what do you see? This is time. So you see a sine, right? So you see a sine. So y equal to sine x. Sometimes you call x, sometimes you call theta, sometimes you call alpha, sometimes you call beta. You can call anything you want. This is where the sine came from. So now that we know that where the sine came from, let's put all 6 trigonometric functions, right? Okay, so the first one is sine, second one is cosine, third one is, let's see, tangent, fourth one is reciprocal of this one, so secant, one is secant, and this one is reciprocal of tangent, so cotangent. All right, now one thing you notice that there is no angles, right? We have to put the angles because trigonometry is the relationship between angles and their side. So then this is sine theta, this is cos theta, this is tangent theta, and this is cosecant theta, this is secant theta, and this is a cotangent theta. There are many ways of writing this one. You can use you can also use numeric, and that is so ka toa, right? So if you do use this one, you can call this one is opposite over hypotenuse, or you can call this one a over c, or you can call this one y over r, or you can call this one sine over r. Okay, similarly, you can call this one adjacent over hypotenuse, or you can call this one b over c, or you can call this one x over r, right? Or you can call this one cosine over r. Okay, the tangent theta, similarly, you can call this one opposite over adjacent. or you can call this one A over B, or you can call this one y over x, or you can call this one sine theta over cosine theta. You can call this one cosecant. Of course, you can call this one reciprocal of this one. So h over o, right? You can call this one c over a. You can call this one r over y, and you can call this one over sine theta. So you can call it 1 over sine theta. So it's reciprocal of that one. Okay. Second is h over a, and then c over b, r over x, and then r over cosine theta. And then finally, we're going to do cotangent. Cotangent is the reciprocal of tangent, which is a over adjacent over opposite, b over a, x over y, or cosine theta over sine theta. Now that you have some background, we're going to go ahead and do those trigonometric addition. And vector b, which is also 3, vector b also 3 Newton, right? Concurrent force. What is concurrent force? When all the forces acting on the same point, we're going to call it concurrent force. So all the forces acting on the point. All right, so two forces acting on this, A and B. All right, A has two components, AX, because we are talking about 2D, AY, BX, BY, right? What is A? A is 3 Newton, and what is X? X is cosine 0 degree, 3 sine 0 degree. Okay, what is B? B is 3 cosine 0 degree. All right, what is B? B is 3, 1 is sine 0 degree, right? So 3 times cosine 0 degree is 1, 3 times sine 0 degree is 0, 3 times cosine 0 degree is 1, and 3 times sine 0 degree is 0. So you have 3, you have 0, you have 3, you have 0, right? Now you have AX plus BX, right? AX plus BX, right? Which is X, which is 3 plus 3, which is 6. And you have AY plus BY, which is Y, which is 0 plus 0, which is 0. So C squared is X squared plus Y squared, right? So C is square root of X squared plus Y squared. So C is 6 squared plus 0 squared. So C is square root of 36. So C is 6. So what do you get? You get A, vector A plus vector B is equal to 6 Newton. So vector A plus vector B, this is how you're going to add, is equal to vector A plus B, right? And that is 6 Newton. This is the sum of two vector, and you're going to call, instead of vector A plus vector B, you're going to call it vector R. This is what we call resultant. Now let's do the same vector. This is, we're going to say 6 Newton, right? Now let's do the second one. Second one, we're going to keep the A same, A 3 Newton, and we're going to make the B is 3 Newton, and this is, we're going to make 30 degree, right? The point, right? Two forces acting on this point, A and B, so AX, AY, BX, BY, right? So this is 3 cosine 0 degree, 3 sine 0 degree, 3 cosine 30 degree, 3 sine 30 degree, right? So this is 3 times 1, this is 3 times 0, this is 3 times 0.86, this is 3 times 0.5, this is 3, this is 0, this is 2.6, and this is 1.5. This is 5.6, and this is 1.5. So square root of 5.6 plus 1.5 squared is 5.8. So this is 5.8. So this one is 5.8 Newton. Now, to add this to vector, right? You have vector A and you have vector B. So this is the resultant. Vector R. R is 5.8. Okay, good. This is problem number 2. Okay, now let's see problem number 3. Problem number 3, I ask you to do problem number 3. Vector A is 3. Vector B is, of course, 3. And this is 90 degrees. So you have a point where the force acting on, right? You have a point where the two forces acting on, A and B. So A is 3 cosine 0. I'm sorry, ax, bx, ay, bx, by, right? Ax is 3 cosine 0, bx is 3 sine 0, um, ay is 3 sine 0, bx is 3 cosine 90, and 3 sine 90, right? So this is 3, this is 0, this is 0, this is 3. So this is 3, this is 3, right? Okay, so this is your x and this is your y, right? So c is equal to x squared plus y squared. So c is equal to 3 squared plus 3 squared, right? So c is equal to 9 plus 9, 18. So 4.2. Good. So 3 is you get 4.2. So now you have vector A, you have vector B, right? Vector A, vector B. This is the resultant. A plus B. You don't call A plus B, you call it resultant. And resultant is how much? 4.2 Newton. Move on to problem number 3. Problem number 3. No, problem number 4. Problem number 4. Okay. So let's do problem number 4. Problem 4, I gave you two vectors, 3 Newton, and of course 3 Newton. Vector A is 3 Newton, vector B is also 3 Newton, and I give you 120 degree. All right, so there is a point where two forces acting on it, two forces A and B, AX, AY, BX, BY, right? So AX is 3 cosine 0, 3 sine 0, right? 3 cosine 90, 120, and 3 sine 120. So this is 3, this is 0, 6, 2.6. So this is gonna give you 1.5, and this is gonna give you 2.6. What do you get? 1.5 squared plus 2.6 squared. That gives you 3. So this one gives you 3. Okay, so this is gives you 3. So how you want to draw that? So you can draw this. You can draw this, and this is A, this is B, right? And this is R. R is 3 Newton. Okay, let's do the last one. Last one is you have vector A and you have vector B, right? And the angle between two is 180. You have a point, two forces acting in this point, and every point, every force has two components because we are dealing with a two-dimensional 2D. So AX is I don't know, 3 cosine 0 and 3 sine 0, 3 cosine 180, 3 sine 180. So this one must be 3, this one must be 0, this one must be negative 3, this one must be 0. This one and this one is 0, this one and this one is 0. So C is equal to x squared. This is x, this is y. So x squared plus y squared, right? So this is 0 squared plus 0 squared, and C is 0. And how you can draw this? This resultant, this you cannot draw. The resultant, you just write resultant is 0 because the resultant is 0. And that was what we discussed today, right? So now at the end, how many possibility you have? Okay, 3 plus 3. How many possibility you have? You have infinite possibility between 0 and 6. All right, is there any angle that can give you 6.1? No. Is there any angle that can give you 5.9? Yes, there is an angle that give you 5.9, and that angle probably, I don't know, that angle probably between 0 to 1. Okay, that give you 5.9. What angle gonna give you R 5.9? Okay, if I ask you what angle gonna give you resultant 5.9, then that angle must be very close to what? Close to 1 degree, very close to 1 degree, or maybe very close to 0 degree, right? 0 to 1. And what angle gonna give you resultant 0.0001, right? What angle? Very close to 180 degree. Okay, this is what we discussed today. So 3 plus 3 give you a million of possibility. What is the maximum you can get? 3 plus 3 when the angle between them is 0. And what is the minimum you can get when the angle between them is 180 degree? Okay, I'll see you tomorrow.